Okay, hello everyone. I want to do a video on, well, I'm in the process of building my generator again, and it's kind of interesting getting all the parts getting laid out and putting it all together. I wanted to show this little demonstration one more time real quickly without that little circuit board that I had on it before, just to kind of show just one more time the transformers and what exactly happens. As everybody knows, this is what a transformer is. It has a wound of thin wire and a wound of thick wire, and they're not directly connected together, but there's just one wire each, and they're but one's wire going in, one's wire going out. So that's what these are. So when we're stepping the current down, we're coming in through the thin wire. So these two wires right here that have these two wires right here that have 129 are connected to two thin wires that are wrapped around this piece of metal a bunch of times, and then down here is the thick wire, and it's coming out the thick wire as, let's see, as 14 volts. But if we take that 14 volts and we run it through a thick wire and another one, a transformer just like this one, and we take the two wires that are connected to the thin wire and we see what the voltage is coming out of that, it is 127. See, so that's what this transformer is. The transformers are spools of thin and thick wire, and if you run the current in through the thin wire and you test to see what comes out the thick wire, it's a lower voltage. But when it goes through the thin wire, it's a higher voltage. So it's very interesting how the effect of the step up and step down transformer has when you look at what's exactly going on with the flywheel and the generator and the magnetism and everything. Because what's going on with the flywheel here is that the magnets are going to be in these positions right here on the flywheel, where I got these pieces of tape. That's where I'm going to mount them. And what's going to happen is I'm going to have coils like this, and I'm going to have really thick wire wrapped around the coils, and they're going to have iron cores in them. They're going to look like this. See, and these iron cores these cores here are, they have a bunch of layers, and the thick wire is going to be wrapped around them like this, and these coils are going to be mounted away from them, and these magnets are going to be mounted to the wheel. But I'm going to have really thick wire like this wrapped around these. So as these magnets are spinning on the edge of this wheel, and they're mounted to the wheel, and these are mounted, and I'm going to use these white ones over here, but when they're mounted away from the magnets, and you take a thick wire like this one and you run it through two coils that have these iron cores in them, then you have two ends of those wires getting north-south magnetic pole vibrations in the metal, back and forth in the coils here. And it's going to be the thick wire that then those two ends are then going to be connected to the two ends of the transformer here. And the transformer here is going to take those two currents from the thick wire, and it's going to run through this back and forth. So it's going to have an alternating current, and then this is a thin wire. The thin wire has a higher voltage, and it's just a single wire. See, if all these wires that are connected to it, they have a ton of like thin wires in them. You see, like this. See, they have a bunch of, there's a bunch of thin wires in it. And if you ever take a magnet and ever get it close to an exposed wire like this that has electricity going through it, you can feel the magnetization. You can feel the vibrations back and forth that are happening in the wire. And it's kind of interesting, because if you look at just a regular little motor like this one, all these two coils right here, all they are is just one thin wire. And if you don't run and you can run this directly off the wall. You know, you can plug these two little thin wires into the wall, and this thing will run like if it was plugged in. I could show that in another video, but not right now. But basically, it doesn't have to run through a transformer. So picture this: you got these magnets on the edge of this wheel that are whizzing by, going north, south, north, south, north, south, and it's making these vibrations. The electrons go back and forth in this coil because of the metal, and they're mounted apart. And then it gets, instead of getting sent through this, the two thick wires just get run to the two thin wires here, and this starts to run just like if it was plugged in. You see the magnets here going through a thick wire connected to two thin wires. So these are like instead of having a thin wire coming out the top here for high voltage 120 like I showed here, you would have it. These are the two step-up transformers. You see, these are the two thin wires that the thick wire is now connected to. So as soon as I get this all built, I'm gonna cut these off, and I'm gonna get the single thin wire here, because this is just one wire wrapped around a piece of metal a bunch of times. That's what this is too. So I'm gonna take that one thin wire, I'm going to run it to the two thick wires that are going to be in my coils that are around this wheel, instead of running it through a transformer like this. This is a transformer that I can step up the current to 120, but instead of stepping it up, you can just run it to two little coils that are in metal like this, and it'll step it up just by this way they're wound in the metal. So this is just like a step-up transformer, just without the thick wire. It's kind of interesting. And the same thing goes with the DC motor too. See, if you look inside, it's just one thick wire, and this is just one thick wire. So I'm going to be running just one thick wire, you know, around the coils like this. You know, as thick as I can get it, just like that. Because the higher the amperage that are around the coils, the more voltage power you can get in the thin wire when you connect it to the thin wire. So it's like you got magnets that are whizzing by coils of thick wire, and those thick wires are connected to two thin wire eventually, and you get, you know, like a bunch of current from a thick wire going into, you know, it's kind of like attaching a nozzle to a hose almost, you know, if you can kind of picture that. But well, okay, well there's one more thing that I got to go over too, real quickly before I cut this off. There's also these ferrite wheels, or not wheels, but ferrite rods that are put in the shape of a wheel or a ring, and what they do is they increase the amperage of the current, so you can actually run multiple things on one current. You know, this is kind of like how a power strip does. You know, like the current comes in and it goes through these thick wires that are around this ferrite rod ring, and then it comes out at a higher amperage, but as a reduced current. So I made a couple of them here, but basically that's what you have to do if you want to run like more than one thing on one line. It's good to have that, because then it increases the amperage or whatever. But I'm going to test that out a little bit more when I get this all running. But I just wanted to show the interesting relationship between the thick wire, the magnets, and the thin wire in the motor that gets run by a higher voltage. So okay, that's my video for now, and I got to start working on this, get the magnets all mounted, so I got to get back to it. Thanks for watching, and I'll post up some more videos soon when I get this all hooked up and ready for another video. Stay tuned, and hopefully I'll post another video soon.